In 1954, Maserati introduced the 250F with a 2,493 cubic centimeters straight six producing 240 horsepower at 7,400 RPM. This is the story of an engine that powered Juan Manuel Fangio to his final world championship in 1957, serving as the backbone of Formula One's 2.5-liter era. Gioacchino Colombo, Vittorio Bellintani, and Alberto Massimino designed it as both a customer and works engine, creating a power plant that remained competitive from the first race of the 2.5-liter Formula in January 1954 to its last in November 1960. The 2.5-liter Formula and Maserati's opportunity. Formula One regulations changed dramatically for 1954. The FIA mandated 2.5-liter naturally aspirated engines or 750cc supercharged units, replacing the previous 2.0-liter Formula 2 regulations that had governed championship racing since 1952. This shift provided Maserati an opportunity to return to Grand Prix racing's forefront after struggling against Ferrari's dominant 500 during the Formula 2 era. Maserati faced Ferrari across the city of Modena. The Orsi family, who had purchased Officine Alfieri Maserati from the Maserati brothers in 1938 and relocated the factory to Viale Ciro Menotti in Modena, needed a competitive response to Ferrari's anticipated 2.5-liter design. Giulio Alfieri led the technical effort as the company's chief engineer, working alongside Gioacchino Colombo, who had recently joined from Ferrari, plus Vittorio Bellintani and Alberto Massimino. The 250F project began as a customer car initiative. Maserati had refined the art of selling competitive racing cars to privateers throughout the 1930s and early 1950s. This business model allowed the factory to generate revenue while maintaining a presence in Grand Prix racing without bearing full works team costs. The approach proved unusual for the era. Most manufacturers either fielded works teams exclusively or sold only previous season cars to privateers. Mercedes-Benz announced their return to Grand Prix racing for 1954, recruiting Juan Manuel Fangio for their driver lineup. However, Mercedes would not debut until the French Grand Prix in July. This gap provided Fangio freedom to drive for another team through the early season races. Maserati seized this opportunity, offering Fangio a competitive car for the Argentine Grand Prix in January 1954. The financial constraints facing Maserati shaped their development approach. Unlike Ferrari, which had far greater funding for its 1954 program, Maserati operated with limited resources, relying on clever engineering rather than costly experimentation. With the regulatory framework established and Mercedes' delayed entry confirmed, Maserati's engineers focused on developing an engine that balanced performance, reliability, and manufacturability for both works and customer applications. Engineering the straight-six architecture. The 250F engine evolved directly from Maserati's A6 GCM 2.0-liter Formula 2 power plant. Engineers bored out the existing architecture to meet the 2.5-liter regulation limit, creating a 2,492.5 cubic centimeters displacement through 84-millimeter bore and 75-millimeter stroke dimensions. This over-square design, with a bore exceeding the stroke, allowed higher engine speeds and better breathing at high RPM, contrasting with some Ferrari designs that occasionally opted for longer stroke for mid-range torque. Colombo specified aluminum alloy for the engine block, a construction method that reduced weight compared to iron blocks while providing adequate strength for racing applications. Wet-cast iron cylinder liners, in direct contact with coolant, were inserted into the block, allowing replacement after wear without scrapping the entire casting. This modular approach reduced long-term operating costs for both works teams and privateers, who needed frequent rebuilds. The crankshaft ran in 7 plain bearings, which provide superior load distribution compared to fewer bearing designs. Vandervelde thin-wall bearings lined each journal utilizing lead-bronze indium composition that allowed tighter tolerances and reduced friction compared to earlier bearing materials. The steel crankshaft featured 6 throws in a conventional inline configuration, with each connecting rod journal offset 120 degrees to balance firing impulses across the 6 cylinders. Double overhead camshafts operated 2 valves per cylinder, a proven architecture that Maserati understood thoroughly from their voiturette racing programs of the 1930s. The camshafts drove off the front of the engine through a gear train, providing precise valve timing without the maintenance concerns of chain drives. Each camshaft opened either all intake or all exhaust valves, with valve clearances adjusted through shim and bucket tappets that required periodic measurement and replacement during rebuilds. A dry sump lubrication system stored oil in a separate tank rather than below the engine. This arrangement allowed the engine to sit lower in the chassis, improving the car's center of gravity and handling characteristics. The system used a scavenge pump to draw oil from the engine sump continuously, then returned it to the remote tank after filtering and cooling. This design also prevented oil starvation during hard cornering, a critical reliability feature for endurance racing applications. Fuel delivery and ignition systems. 3 Weber 42 DC03 twin-choke carburetors fed the engine in initial 1954 specification. Each carburetor supplied 2 cylinders through individual intake runners, providing better fuel distribution than a single large carburetor while maintaining simpler tuning compared to individual carburetors per cylinder. The Weber design used downdraft mounting, with air entering from above and flowing downward into the intake ports. This configuration improved cylinder filling at high RPM compared to side draft arrangements. The fuel mixture for 1954 consisted of 50% methanol, 35% gasoline, typically 80 octane, 10% acetone, 4% benzol, and 1% castor oil. This complex blend provided cooling through methanol's high heat of vaporization, while the gasoline component ensured reliable ignition. Acetone increased flame speed for more complete combustion, benzol raised the effective octane rating, and castor oil provided upper cylinder lubrication. This mixture became standard for naturally aspirated Formula One engines during the 2.5-liter era. Compression ratio measured 12:1 in 1954 specification. This figure balanced power output against the risk of detonation with period fuels. Higher compression ratios increase thermal efficiency and power production, but excessive compression causes premature ignition that destroys pistons and connecting rods. The 12:1 ratio represented careful calibration based on available fuel quality and combustion chamber design. Marelli supplied the magneto ignition system. Magnetos generate their own electricity through a rotating magnet and coil assembly, eliminating dependence on battery power. This self-contained design provided reliability crucial for racing, as electrical system failures would not affect ignition. Each cylinder received 1 spark plug positioned in the combustion chamber crown, with plug threads measuring 14 mm diameter. For 1955, Maserati introduced optional fuel injection using SU equipment. The injection system replaced the 3 Weber carburetors with individual injectors spraying directly into each intake port. This arrangement provided more precise fuel metering and eliminated the altitude sensitivity of carburetors, which required rejetting when racing at different elevations. With fuel injection, power increased to 240 horsepower, a gain of 20 horsepower over the carbureted specification. The injection system operated mechanically, driven off engine speed and throttle position without electronic controls. A pump pressurized fuel to approximately 80 pounds per square inch, then distributed it through calibrated metering units to each cylinder's injector. This mechanical simplicity aided reliability, but required skilled mechanics to calibrate properly across the engine's operating range. Ignition timing advanced through mechanical and centrifugal systems within the Magneto. Power development through 7 seasons. The initial 1954 specification produced between 220 and 240 horsepower at 7,200 to 7,400 RPM, depending on tune. This output matched the 250F's design brief, providing competitive power without sacrificing reliability. Peak torque occurred at approximately 5,500 RPM, giving strong mid-range pull for corner exit acceleration. Privateers could rev the engine to 7,200 to 7,400 RPM reliably, while works drivers occasionally exceeded 8,000 RPM during qualifying sessions, accepting reduced engine life for maximum performance. Engine development continued throughout the 250F's racing career. Weber 45 DC-03 carburetors replaced the original 42mm units in April 1955, increasing air and fuel flow to support higher power output. Larger carburetor ventures reduced restriction at high RPM, though proper jetting remained critical to prevent lean conditions that destroyed pistons. By 1957, the final evolution of the straight six produced 270 horsepower at 8,000 RPM. This 50 horsepower increase over 3 seasons came through accumulated detail improvements, higher compression ratios approaching 13:1, revised camshaft profiles extending valve lift and duration, larger intake and exhaust port dimensions, and optimized combustion chamber shapes. Each modification required extensive testing to ensure reliability alongside the power gains. Engine life varied dramatically between works and private specifications. Works engines required complete rebuilds every 500 miles of racing, as engineers pushed tolerances and RPM limits for maximum competitiveness. This frequent maintenance included replacing piston rings, bearing shells, and inspecting all reciprocating components for fatigue cracks. Private owners rebuilt at longer intervals, typically 1,000 to 1,500 miles, by limiting peak RPM and accepting slightly lower power outputs. The 280 horsepower figure quoted in period sources represents the maximum work specification under fresh rebuild conditions, while most race engines produced around 260 to 270 horsepower power loss through a race weekend was minimal, and mainly due to wear and compression drop. Contemporary competitors included Mercedes-Benz W196 producing 290 horsepower at 8,500 RPM from 2,496 cc, and Ferrari's various 2.5-liter designs outputting 260 to 270 horsepower. The Maserati straight six's advantage lay not in peak power, but in broad torque delivery and proven reliability that allowed privateers to race competitively without factory support. Manufacturing tolerances achieved remarkable precision for 1950s standards. Fangio's championships and racing glory. Juan Manuel Fangio drove the 250F to victory in its debut race, the 1954 Argentine Grand Prix, in January. Rain fell on race day at Buenos Aires, favoring the Maserati's handling over Ferrari's faster but more difficult 625. Fangio led throughout, finishing over 1 minute ahead of Giuseppe Farina's Ferrari. This immediate success validated Maserati's engineering approach and announced the 250F as a serious competitor. Fangio won again at the Belgian Grand Prix in June 1954 at Spa-Francorchamps, before departing for Mercedes-Benz as planned. His 2 victories contributed to his 1954 World Championship, though he scored points with both Maserati and Mercedes during the season. Sterling Moss purchased his own 250F privately, racing it throughout 1954. An unprecedented arrangement where a privateer could buy a current specification factory race car. Mercedes dominated 1955 with Fangio winning the championship, but Maserati continued developing the 250F. The factory introduced a 5-speed gearbox in July 1955, first appearing on Roberto Mir's car at Aintree. This additional ratio improved acceleration and top speed on circuits with varied corner speeds. Dunlop disc brakes were tested on selected cars during 1956 and became standard in 1957, providing superior stopping power and fade resistance to the earlier finned drums. Moss returned to Maserati for 1956, joining John Barra in the works team. Moss won at Monaco and Monza, finishing second in the championship behind Fangio, who had moved to Ferrari. The 1956 season marked Maserati's closest challenge to Ferrari for the Constructors' title, though no official Constructors' championship existed yet. Fangio rejoined Maserati for 1957, his final season. The team comprised Fangio, Behra, and Harry Schell. Supported by occasional drivers at specific races, Fangio won the Argentine Grand Prix, Buenos Aires City Grand Prix, French Grand Prix at Rouen, and German Grand Prix at the Nürburgring. His German victory became legendary. A botched pit stop left him 48 seconds behind Mike Hawthorne and Peter Collins in their Ferraris, with 22 laps remaining. Fangio attacked relentlessly, breaking the lap record 10 times during his charge. He caught and passed both Ferraris on the final lap, winning by 3.6 seconds. This drive, which Fangio considered his greatest, demonstrated both his skill and the 250F's capabilities when pushed beyond normal limits. The engine survived maximum RPM for extended periods, testament to the durability Colombo and Bellantani engineered into the design. Fangio clinched his fifth and final world championship at the age of 46, a record that stood until Michael Schumacher's 2003 title. Financial pressures mounted throughout 1957 as Maserati struggled with mounting debts and national economic difficulties. Financial collapse and the final years. By late 1957, various financial problems forced Maserati toward bankruptcy. The factory had spent heavily on both their Grand Prix program and sports car racing efforts. While revenues failed to cover expenses, some creditors offered debt forgiveness if Maserati captured both the Drivers' Championship and Sports Car Championship. For 1957, Fangio delivered the drivers' title, but a disastrous race in Venezuela, where all works cars crashed, including 2 cars hitting each other, allowed Ferrari to win the Sports Car Championship. The factory closed its racing department after the 1957 season. However, Maserati continued servicing customer cars and sold off works chassis to privateers. The Italian government intervened, placing Maserati under controlled administration to prevent total collapse, though racing budgets remained unavailable. The 1958 season marked a fundamental shift in Formula One. Cooper introduced successful mid-engine designs powered by 2.0-liter Coventry Climax engines, proving that smaller engines in lighter chassis could compete. The front-engine era ended rapidly as teams recognized the handling advantages of mid-engine layouts. Maserati's front-engine 250F became instantly obsolete despite competitive power. Privateers continued racing 250Fs through 1960, the final year of the 2.5-liter formula. The car remained popular for its availability, known reliability, and reasonable operating costs. Maria Teresa de Filippis became the first woman to race in Formula One, driving a private 250F in 1958. While no longer competitive for victories, the 250F filled grids and provided racing opportunities for drivers who couldn't secure factory rides. 26 250F chassis were built between 1953 for interim A 6 GCM/250 conversions and 1958, the last new chassis, called Piccolo, for their smaller dimensions and lighter construction, appeared in June 1958. These final cars featured shorter wheelbases and reduced weight, but arrived too late to matter competitively against mid-engine designs. Valerio Colotti, the chassis designer, attempted one final 250F evolution after leaving Maserati. His TechMech project used 250F engine and components in an all-independent suspension chassis with modern features, but appeared only once at the 1959 United States Grand Prix at Sebring before falling into dereliction. The 250F competed in 46 Formula One World Championship races with 277 total entries, scoring 8 victories. Legacy of the Straight Six. The 250F Straight Six achieved remarkable longevity beyond its original racing application. In 1966, Maserati revived their V12 engine project that had appeared briefly in 1957. Cooper bought these engines for the new 3.0-liter formula, bored out to 2,989 cubic centimeters. Though the V12 represented different architecture, it drew on knowledge developed through the Straight Six program. This engine powered Cooper T81 and T86 chassis from 1966 to 1969, scoring 2 victories before Cooper's withdrawal from Formula One. The final Maserati-powered Formula One entry occurred at Monaco in 1969. Vic Elford drove a Cooper entered by Colin Crabb's Antique Automobiles team, appropriately named given the car's outdated design. This appearance closed Maserati's presence in Grand Prix racing that had begun in the 1920s with their first competition engines. Stirling Moss later declared the 250F the best front-engine Formula One car he drove, praise from a driver who raced virtually every significant Grand Prix car of the 1950s. His assessment highlighted the 250F's balanced handling, predictable behavior at the limit, and the satisfaction of driving a properly engineered machine. The car's longevity, present at both the first and last races of the 2.5-liter formula, demonstrated the soundness of its fundamental design. The 250F created what became known as the cult of the chassis numbers. Multiple museums claim to possess chassis 2529, the specific car Fangio drove to victory at the Nürburgring in 1957. This confusion sparked detailed chassis research and record-keeping that became standard practice in historic motorsport. Enthusiasts began tracking individual chassis numbers and race results meticulously, a practice that continues today with modern Formula One. Original 250F engines remain highly valued, with owners often choosing to preserve original engines rather than install rebuilds or replicas. The engines produce a characteristic baritone exhaust note, singing smoothly from idle through the mid-range, before gaining intensity above 4,000 RPM period power outputs of 240 to 270 horsepower, came with torque delivery that modern drivers describe as supremely impressive between 4,000 and 6,000 RPM. The engineering approach Colombo, Bellintani, and Massimino established, prioritizing reliability alongside performance, designing for customer use, not just works teams, and building sufficient production capacity to supply privateer demand, influenced subsequent racing engine programs throughout the 1960s. The Maserati 250F Straight Six demonstrated that sound engineering executed well could compete against wealthier manufacturers. Colombo's team created an engine producing 220 to 270 horsepower across 7 seasons, powering Fangio to his final championship and remaining competitive in privateer hands long after the factory withdrew. The Straight Six's influence extended beyond statistics, establishing practices for customer racing engines and proving that durability and broad torque delivery mattered as much as peak power in Grand Prix competition.